Hello everybody, I am Mahmoud Hafezieh from Iran, Iranian Fisheries Sciences Research Institute, and my topic is Artemia enrichment for sturgeon fish larvae. This is the Caspian Sea, the biggest lake in the world, which at the north of this sea there is fresh water, but the northern part of Iran, I mean that the southern part of the Caspian Sea, that is not exactly saline water, but also brackish water. I mean near to 11 to 13 ppt. And we have sturgeon's fish, which is very famous in all the world. And you see the pictures of 5 native species: Accipenser and Hoso genus. In this figure you see the CPUE, which showed the fluctuations, but unfortunately you can see the decreasing of this fish catchment because of overfishing, because of lack of effective management, unfortunately pollution and illegal trade. And we have 4 centers for artificial spawning and restocking the sturgeon fingerling directly to the rivers go to the Caspian Sea. You see in 1993 more than 4 million fingerlings, and in 2015 more than 21 million fingerlings released to the Caspian Sea, based on the activity that we have done in these 4 centers at the northern part of Iran. For that cases, we use the broodstock of different species. Mainly in this project we use Accipenser persicus, and you see the artificial breeding, and what is our problem in those 4 centers for restocking. Unfortunately, after fertilization of the eggs and the hatching, we have high mortality of larvae, maybe because these fishes is anadromous. We must release directly to the river, and we have some problem in our rivers at the northern part of Iran. Another is decreased resistance the produce larvae against environmental stress, and decrease of the growth rate in larvae culture period. And why we have some problem? Because we have degradation of the natural habitats, river pollution, drought years, dam construction, and unfortunately bycatch fisheries. As every experts know, for increasing survival and growth rate of the fish, we can do 3 strategies: good management, vaccination, and using the best feed for nutrition. I mean, we must requirement we must know the requirement of the fish nutrition, and we must prepare the fatty acid, vitamins, protein, and so on. Of course, with these three strategies, we improve the immune responses and health status, and finally we have good survival and growth performance. And one of the most exciting procedure for improvement the nutrition in the fish larvae, it is used of monopoly of Artemia, but before we use, we can enrich with different matters such as essential nutrient, vitamins, pigments, fatty acid, and something like this. By this procedure, we give a bioencapsulated feed directly to the gastrointestinal of the fish. Okay, what is the objective of our project? It is to determine the effects of different HUFA oil concentration, enrichment period, and vitamin C level on growth, survival rate, salinity tolerance, and vitamin C in Persian sturgeon fish larvae, and the possibility of releasing larvae directly to the Caspian Sea is another objective that we have done in this project. And the experiment is the effect of HUFA oil supplemented with vitamin C levels during 2 enrichment period, growth rate, survival percentage, SGR, FCR, CF, vitamin C accumulation, crude protein, lipid, and fatty acid compositions of Accipense persicus larvae, and finally salinity tolerance in these larvae for 6, 12, and 8 ppt at different hours. As material and methods, first we prepared the Accipense persicus larvae. As a preliminary, we must to hatch the Artemia romiana cyst, enriched these napoli with vitamin C 10, 20, and 30% in HUFA oil. We use ICAZ-2020/4 and sturgeon ovary oil for feeding Accipense persicus larvae between 4 to 20 days after hatching, and during 12 and 24 hours as enrichment period, and calculation of measurement of vitamin C of Artemia urumiana and Accipense persicus larvae before and after enrichment, which HPLC method, measurement of crude protein by using Kegel-Dahl method, total lipid using Saxelet method, fatty acids using gas chromatography, total length, total weight, and SGR, FCR, CF, and survival as a percentage in Accipense persicus larvae. And for salinity test, we put the larvae in different saline water such as 6, 12, and 80 ppt for 6, 12, 24, 48, and 72, and finally 120 hours. And for the analyzing statistically, we use ANOVA with Turkey's multiple range test in 95% confidence interval. Okay, this is the preparation of larvae. This is the salon that we use 3 40 liters tanks for each replication, containing 25 liter well water with 1 liter per minute per tanks as a flow rate. This is the hatching of Artemia oromia cyst room, and collection of hatched nauplii with using the light trap, the counting the nauplii, and enrichment. This is the procedure for enrichment of Artemia nauplii, one at 12 hours and finally at 24 hours. We use HPLC, Kagel and Saxele for measurement of different parameters. Here you see the procedure for larval rearing and monitoring for water quality. Of course, measurement using the devices. And this is our experiment. I means two-way ICES and estrogen ovary oil with different percentage of vitamin C, namely T25 to T36. And in this study we found the main factors, I means the oil, Hufa oil and vitamin C. An enrichment period had not effects on growth, but the combination of oil sources, vitamin C levels and enrichment period significantly affected on total length in sturgeon fish larvae. ICES supplemented with 20% vitamin C during 12 hours enriching was the best combination and had significant effects. Oil sources and vitamin C levels significantly affected on FCR in sturgeon fish larvae, but enrichment period and combination of three main factors had not any effects on FCR. Here you see the survival percentage of larvae in 12 ppt salinity stress test. The control after 48 hours completely died but other treatments fortunately have good survival rate even after 120 hours at 12 ppt salinity. This is the figure before salinity test of survival rate of larvae when they enrich with Hufa and vitamin C. There is no any differences between control and other treatments. This is after salinity test in 12 ppt salinity at 120 hours. You see the differences between the main factors here. I means the different oil, different percentage of vitamin C and different period of enriching, but between the combination also you can see the differences significantly. In the present work, the supplementation of vitamin C as ascorbyl palmitate to the Artemia enrichment had a positive effect on sturgeon larvae survival and salinity tolerance. The maximum survival percentage was obtained in larvae enriched with ICES supplemented with 20% vitamin C at 24 hours. It is almost 91%. All the treatments including the main factors and combination increased the tolerance of sturgeon larvae in 12 ppt, which is the same salinity of the Caspian Sea. Approximately in all cases, more than 95% survival were reported after 120 hours, but in salinity at 80 ppt, all sturgeon larvae were dead after 24 hours. In this respect, vitamin C supplementation in live food enrichment can be a practical means to improve survival and stress resistance of sturgeon fish larvae prior to restocking and or transfers to intensive culture. As HUFA-enriched Artemia supplemented with vitamin C had a positive effect on vitamin C, crude protein, lipid, and fatty acid accumulation in sturgeon fish larvae. Here the vitamin C content in fishes in different treatment, main factors and combination. You can see all the treatments, combination and factors have significantly increased the vitamin C content compared to control. Here the protein contents. Here you see the lipid contents. Of course, the saturated fatty acid contents and the mono fatty acid contents, arachidonic contents, EPA contents, DHA contents, and the ratio DHA EPA ratio. It is very most important ratio for showing the changes of DHA EPA in the larvae. In some cases, such as ICES, with 10% vitamin C after 12 hours enrichment, it is the higher ratio, but the others compared to the control is not so high. This is the omega-3 omega-6 ratio. It is not good compared to controls. And finally, vitamin C as ascorbic acid is considered to be an essential component in diets for fishes. Fish larvae are particularly sensitive to vitamin C deficiency, and addition of vitamin C to larvae diets improves survival, growth performance, skeleton development, stress resistance, and immune response. We found no relationship between HUFA enrichment and larval survival. Moreover, the survival of sturgeon fish larvae fed Artemia enriched with HUFA supplemented with vitamin C when placed in high salinity such as Caspian Sea water was significantly higher than fish larvae fed Artemia enriched with HUFA only. Then the supplementation of vitamin C as ascorbyl palmitate, which is we used in this procedure to Artemia enrichment, had a positive effect on sturgeon larvae survival and salinity resistance. When sturgeon fish larvae fed HUFA Artemia enriched supplemented with vitamin C, the survival rate in laboratory condition and also in high salinity, I mean 12 ppt, were increased significantly due to the effect of optimal level of EPA and DHA. Although DHA content in Artemia aurumina nanoply enriched with ICES and Artemia aurumina enriched with ICES supplemented with vitamin C significantly increased compared to the Artemia control, I mean no enriched, but the DHA amount in the sturgeon fish larvae fed ICES, Artemia enriched, and the fish larvae fed ICES supplemented with vitamin C did not show noticeable increasing compared to the fish larvae fed Artemia non-enriched. EPA content showed increase in fish larvae, but DHA, EPA, and omega-3 omega-6 ratio of sturgeon fish larvae fed ICES Artemia enriched with or without vitamin C also were influenced and decreased compared to the fish larvae fed Artemia non-enriched. Thank you for your attention.